In this video I'm going to be demonstrating how to get started creating procedural animations using Control Rig. I'll be showing it with a basic example of adding recoil animations to a weapon model. The first step once you've launched your project is to enable Control Rig, and you can do this from the plugins menu and searching Control Rig. Tick Enabled and it will ask you to restart the editor. Once the editor is restarted, Control Rig will now be enabled. If you right click in the content browser and go to Animation, you will now see Control Rig. Click this to create a Control Rig. Select Control Rig as the parent rig. Name this whatever you'd like, double click to open it, and here you will need to import a skeletal mesh. So if you don't already have one, I've included in the description a link to the USP model that I'm using for this demonstration so you can follow along, or you can use your own model. So you click Import Hierarchy, and then select the mesh, and click OK. This will import the bones into Control Rig so you can now use them to manipulate the animation and the skeletal mesh. So let's begin by trying to move the entire skeletal mesh. So to do this, right click anywhere in the graph and search for Set Transform. For the type, leave it selected at bone. For the name, select the bone name that you want to move. So in this case, I'm going to use main. As you can see, it's disappeared because we haven't yet set a transform. And also you can see that the other parts of the gun mesh are still visible, and that's because we haven't got Propagate to Children ticked. When you tick that, the entire gun will move to the default transform, which is at 0, 0, 0. So now we need to plug in a transform. So right click again and search for Get Transform. And select the same bone that you used in the Set Transform node. So in this case, main. And now if we plug in the transform to the transform, nothing changes because this is getting the bone transform and setting the bone transform to the same place. But instead, we will want to manipulate this so that the model actually moves. So firstly, tick Initial. This will mean that it will get the transform from the reference pose rather than the current pose. And instead of having transform plugged into transform, plug them in individually, so rotation to rotation, translation to translation, and scale to scale. Now what we can do is drag out from translation and search for Add Vector and plug that back in, and anything we plug into here will offset the bone. So for example, if I plug in 50 on Z, it'll move the gun up by 50 units on the Z-axis. So now what we want to be able to do is control this vector dynamically. So what you'll do in the My Blueprint section, which may be in a different place for you, create a new variable, and we'll call this Time Since Last Shot, and we can rename this later. Change that to a float variable, and compile. You might want to turn off auto compile if you have a complex setup, because it can recompile every time you type in any number or make any changes, and it can be slow. I usually turn it off and then manually click compile. So now we have this new variable which is going to represent how long it's been since the last shot was fired. So if we drag this in and click Get, we can plug that into the Y-axis just as a test, compile, and then when you select this, you should be able to change the default value by clicking and dragging, and as you can see, the weapon model is moving based on whatever number is input into that variable. But what we want to do instead is make it animate based on the time. So instead of using Get Time Since Last Shot plugged directly into Y, we'll instead use Evaluate Curve. So right click again in the graph and search for Evaluate Curve. Plug in Time Since Last Shot as the value, and the result is going to be plugged into Y. So the source minimum is at 0 because the time since the last shot can never be a negative number. The source maximum is 1 because the animation will not last longer than 1 second. The target minimum and target maximum scales the output. So we can start at 0 and let's go to say -8 so that the gun moves backwards. So what we'll see if we compile now, and if we start manipulating the time since last shot value, the output will approach -8. But we don't want it to move gradually backwards, we want it to instantly snap backwards and then slowly decay back to its default position. So to do this, you can drag down the final point, which is currently at 1, back down to around 0. And now you want to add another point to this line. So you can right click anywhere on it and click add key to none. And then drag this up to around 1. So once we compile, what will happen as we drag time since last shot towards 1 is it will quite quickly move towards the maximum, which is -8, and then gradually decay back to the default position. It might be useful, instead of manipulating the time variable, to right click and search for time and click accumulated time and plug this in to the value. What this will do is it will actually simulate the game time, but because it goes over 1, the curve is no longer being used because it goes past this point. So instead what you can do is drag out from that and do a percentage sign and the number of 1, and then it will wrap around every time it reaches 1. So if we compile, it will repeatedly do the same animation. This can be useful if you're trying to get the timing of the animation right. So for example, this looks too slow moving back. So we'll go in and we can move the point so that it quickly moves backwards. And maybe I should turn auto compiling, so I'm going to forget to click that every time. So that's quick. That might be a little bit too quick if you can't see that it's actually animating. So you can just move the point around until it looks something like what you're going for. And now, to make it look less robotic and less linear when it moves back to the default starting point, you can add another point onto this line. So right click anywhere and click add key to none and move it around. And then you can also right click on the point and click auto. This will mean it will be a curve interpolation rather than a straight linear transition. Move this around until it looks approximately like what you're going for. So that will do for now. We can always change this later. So what we're going to do next is move the slide back in the same way that we did this. So you can copy and paste both of these nodes and link it up through the execution path. But instead of using main, we're going to use slide, and the same for on the get bone, we're going to use slide. Now you'll see that this has gone haywire because, well, firstly we haven't got translation plugged in as we plug that in, but you'll notice it's staying in the same place. And that is because it's using the global space from the initial reference pose. So instead of using global space, let's switch both of these to local space. So that's the space that the bone's in. So that is now it's keeping the parent position because we've not offset it at all. So when we repeat the same process of dragging out from translation, searching for add, and plugging it into translation, these numbers will now offset the slide. And the X, Y, and Z are based on the bone's local axis. So if you're not sure which one to use, you can just type numbers in and you can just see which moves it in the direction you want. So that's obviously not it. Let's do 0.5 on Y, and that seems to be it. And that looks a bit too far for how far we want to move it, but it's approximately right. So I'm going to try 0.4, and let's say that's as far back as the slide is going to move. So instead of using a set value of 0.4 for Y, we'll repeat the same process. We can use accumulated time and the curve, and we can plug that in to Y, but instead of the maximum being -8, it's going to actually be 0.4. But now you'll see that the slide is returning to the starting point too slowly because it's exactly the same curve as the entire gun's movement. So what we'll do instead is I'll delete that and move this point to the left. So now it's instantly moving back, and that might be a little bit too fast. So we'll just move this around until it looks about right. And you're not really going for realism here. You want it to look how people would expect it to look in a game. And in reality, the slide probably moves back and forwards too fast to really see. But in games, it tends to be a little bit slower so you can actually see the effect. So just manipulate the points until you think it looks right. So now that looks like the slide is actually delayed because I've moved it too far to the right. So we can just move it around again. And now it looks too slow overall, so we'll move this point as well. And that might be a little bit too fast, so just adjust this until it seems around about right. So let's say that's good enough for now. So now that that looks about right, we're going to deal with the rotation. And there's probably a better way of doing this, but this is the way that I understand it, and this is the way I usually do it. So we're going to be rotating the main bone. So instead of having rotation plugged directly in, drag out from that and search for to rotator. And then from the rotation input, search for from rotator. And now these numbers can be plugged in directly. And everything goes back to normal. But now these numbers can be manipulated to offset the rotation. So in this case, I know that X is the one that I want to manipulate. And let me just move some things around just to get a bit more space. So if I drag out from X and do add float, we can offset this in the same way that we've done. So we'll offset it by 40 degrees. That's obviously not what we want, but now we know that the number will want to go negative. So let's say it'll go up to that as a maximum. So instead of using -20, we can use the same curve again. So let's just copy these 3 nodes. And we'll plug that in. But instead of the maximum being -8, we'll change it to -20. So you can sort of see the idea there. And now it's looking like the gun's not actually moving back far enough. So in the translation for the main gun, I'm going to change the -8 to -12. But now the rotation and the translation is synced up. So I'm going to make some changes so that it looks a little bit more snappier and the rotation and translation aren't directly synced. So all I'm doing here is moving some points around until it looks about right. And now I've noticed that the slide is not really visibly moving back. It may be the frame rate of this window, and I'm not sure how well you'll be able to see that in the video, but I'm just going to adjust it so it's a little bit slower when the slide moves back, and then it should become a little bit more visible. So it moves back slower, and then I'll make it return even slower. And also what you could do is change the speed variable on the time. So rather than using 1, you could see what it looks like in 0.5 speed. And at this point it might make sense to use the same nodes for all of the curves. So let's just replace these. And now if I change the speed, we'll see that the whole thing slows down. So I'll change that from a 1 to 0.5. And I'm going to slow it down even further to 0.25. So now at this speed we can see that some problems with the animation. The gun is returning back in its rotation before the slide has actually reached the back of the gun. So let's make some changes. Firstly, I think I might increase the speed that the slide returns. And then I think the translation of the gun needs to be delayed. And also the rotation is too fast at the start. So I'll make that more gradual. And also I think what I'll do is add another point to the curve so it looks like it starts off a little bit slower with the rotation until the slide reaches its maximum position, and then the momentum is transferred into the gun, which lifts the gun up. This will make it look snappier. And maybe the rotation is decaying a little bit too fast as well. And instead of the curve returning straight back to 0, I'm going to add another point and make it overcorrect in both sides of the curve, and I'll set those both to auto. And now you can see that there's some correction after the gun's fired. And I don't think it's quite doing it fast enough, so I'll rotate the points on this so it's a bit smoother. And I think I'll move it to the left slightly so it happens a bit earlier. And I'll move all the points slightly to the left so that it gets slower over time and it gets back to 0. And it's not looking quite snappy enough again with the movement of the gun, so I'm going to try just manipulating that to see if we can make it look any better. And also you can change the values at any time, so if you want it to move back further you can just change this number, and obviously that's too high. But let's just try some numbers out to see if anything works. And the same with the rotation. So let's see what that looks like in real time. So from this it seems like the gun is still returning back to the default spot a little bit too slow, so I'm going to move that down. I might even move this point in, just so it returns back to the default position a little bit faster. So you'll probably want to spend more time just manipulating these curves, and maybe you could change some other axes if you want. But for now I'll just show you how to implement this into the actual game. But you don't want to use the accumulated time. Instead, you're going to want to use a variable. So in this case, we'll use time since last shot. So we'll plug that in instead. And we actually don't need this node anymore because we don't want it to loop. So control and drag from the output to the output of time since last shot and compile, and now we'll see that nothing happens. So what you need to do next is right click on the skeletal mesh, go to create and do animation blueprint, and open up the animation blueprint. And to get it to use control rig, we need to right click somewhere and search for control rig. Link it up to the output pause. And for the control rig class, we're going to set that to the one we just created, which in my case is USP control rig, and compile. And now what we're going to need to do is input the time since the last shot was fired. But you'll see that there's no inputs to this except for the alpha. So go back to the control rig and select the variable and tick instance editable and compile. Now back in the animation blueprint, we can see that there's a new input which we can tick to input the time since last shot variable. So if we compile that and we input, let's say 0.5 and compile, we'll see that that's moved. It's not too obvious, so let's go 0.1. And we can see that it's actually working. But instead of putting a variable in here, we want it to be dynamic. So what we then need to do is, let's just take the first person character blueprint. So on the input action fire, well, first we should probably add the actual static mesh, so I'll just delete the things we don't need. Set the camera position back to default. So I'll add the skeletal mesh. And for the animation blueprint, I will select the animation blueprint we just created. And then you'll need to spend some time just positioning the weapon so that it looks right. And what I would usually do is attach that to the first person camera so it moves with the camera. So if you see what that looks like, it's obviously in the wrong position. So we will move it forwards and down. So there, that's close enough. So now what we need to do is, whenever the gun is fired, we're going to create a new variable and call it last shot time. And we'll drag that in, choose set, and whenever this is clicked, we'll set the last shot time to the current game time. And now back in the animation blueprint, go to the event graph, and let's do begin. So this is when the blueprint begins, and we'll get the pawn owner and cast it to the first person character. Right click this, promote it to a variable. And now whenever this ticks, we can get the variable, which is last shot time, and we can get the game time in seconds. And the current time minus the last shot time will be how long has passed since the last shot was fired. So then we're going to promote this to a variable and link it up. So this variable can now be accessed from the animation graph. So I'm going to rename this to time since last shot, and it doesn't need to match the variable that's in the control rig, but in my case it will. And compile. And then in the animation graph, we want to get time since last shot and plug that in to the input on control rig. And now if everything's worked, it should play the animation when we click, which it does. But I also noticed another problem. Immediately when the game begins playing, it auto shoots because the default value is set to 0. So the last shot time, it thinks it's shot at the instance that the game starts. So we can just set this to a negative number. And from playing in the editor, I can tell that the slide isn't moving back visibly enough, so I'll probably slow that down and make some other changes. So to do that, you can just go back into control rig and make some changes to see what works best. So I'll probably slow the slide animation down and then see what that looks like. And you may not see much difference on the video, but trust me, it looks shit. And you can keep making changes and tweaking the variables until it looks how you want. And then once you add in the sounds and the muzzle flash effects, you might still need to tweak it further. So all you need to do is just play around with the curves, and you can add in different curves to offset another axis, or you can add some randomization in. And it may seem a little bit convoluted to set this up when it would take only moments to make in Blender or any animation software. But the advantage of this is that you can make it respond dynamically to gameplay events. So for example, you could have randomized recoil, so it's different every time. And there are a lot of advantages to using procedural animations, and this is obviously a basic example just using a simple skeletal mesh, which again you can download in the description. But you can also apply the same kind of techniques to more complex situations. So for example, I'm working on a procedural walk animation system, which is mostly built within Control Rig using the same kind of nodes, just more complex. But you could also use it in various other situations. For example, if you wanted to have hit reactions on a player, so when they get shot they react differently each time or based on where the bullet is. That's not something you'd be able to do without creating many keyframed animations, importing them and choosing which one to select. Instead, you could just pass a variable to Control Rig which says where the shot hit on the player, and then Control Rig would affect how the player has reacted to the shot. So they could rotate away from it or move in the opposite direction from where the shot came from, and things like that, which wouldn't really be possible using keyframed animation. So hopefully this has helped you to get started using Control Rig, and I think most people should be able to follow along. I'm using Unreal Engine 5, but the same works for Unreal Engine 4.26 and 4.27. So like the video and subscribe to the channel if you'd like to see more, and leave a comment if you'd like to see other tutorials covering any other areas of Unreal Engine, and thanks for watching.